This textbook problem is misleading. Like the problem says that we have this equation PV is equals to nRT, where P is pressure of an ideal gas, B is volume, T is temperature, and R is the ideal gas constant, and N is number of moles, right? This is basically a relation between pressure, volume, and temperature of a gas, of an ideal gas, right? And we are asked to prove this relation, and it's like made and it's shown that this relation is show like interesting relation that the ideal can satisfy. But you know what, guys, like this relation is so general that like any function of with three variables will satisfy this one. Let me show you. So over here we have PB is equals to nRT, right? PB is equals to nRT. And yeah, I can write this as PV minus nRT is equals to 0. So that this is basically a function of P, V, and T, right? We are asked to prove that partial P by partial V, partial B by partial T by partial P is equals to negative 1. So now, if we know that like the partial P by partial B, I can write this as minus like the partial derivative of the function, this function with respect to b, by partial derivative of function with respect to p, right? Similarly, I can write partial b by partial t as the partial derivative of function with respect to t. Basically this, the variable in the denominator goes to numerator, in the numerator goes to denominator, by fp, right? Now again, partial t by partial p will just be equal to the negative of the partial derivative function with respect to t, partial derivative function with respect to, sorry, p, and then t, right? Yeah, now if we know this, now this is so obvious. Like now the partial p by partial b, partial b by partial t by partial p, now this is so obvious because we know that this is just negative of fb by fp, and this one is just negative of ft by fb, and this is just negative of fp by ft, right? And now this just cancels out. Now this just cancels out. So yeah, it's obvious that it's negative 1 to the power 3, which is negative 1, right? And so, like, even though, even if the function was just not pb is equals to nrt, even if the function was like pbt is equals to p square v square minus let's say 2nrt cube, even if this was the equation, it would still hold true. Partial p by partial v, partial v by partial t by partial p will still be negative 1 cube, right? And not just these, not just this. Let's say if I have some function of a b c d as some a square b square plus a b c plus b c d, something like that. Again over here also, partial a by partial b by partial c by partial d by partial a, this will also be negative 1 to the power 4, which is 1. And this is not surprising, right? It just follows from this relation that if you want to find partial p with respect to partial d, if you write it as a function, so then that's just negative of the partial derivative of function with respect to partial derivative of the function with respect to, like, first of all the denominator variable and the numerator variable. This can be found in any textbooks with where you will read the partial derivatives. So it's just that. And yeah, now you might have seen that uh, it's definitely misleading because it holds for any variable, like any equation, not just this one, right? Definitely you can, if you want, definitely you can try to verify this for yourself. I had already done that for myself, but that takes time, so you might want to do it on your own. But yeah, this is nothing special, don't get surprised. Okay, if this comes in your textbook, this is not anything like surprising that ideal gas holds true. So yeah, guys, I hope you love this video, and yes, do so with your friends. I hope you learned something new. And yeah, that's it for today.